We've got our app skeleton that can potentially present lots of interesting content, except we don't yet have any content. The intended content of our app is dynamic. It's constantly changing, and there is no reasonable way for us to pack it within our application. We must get it from outside, so we need to implement what's called networking. Networking is simply managing request-response combination. Our code needs to send the request to some remote server following a specific format and wait for a response, or acknowledge no response. There is a set of objects in Swift that help us do this. Let's explore those and prepare our app for getting the content we need.
Now we are going to learn the basics of networking. Networking is simply managing a request-response combination over the network. Our code needs to send the request to some remote server following a specific format and wait for a response, or acknowledge no response. Communicating with an external resource adds a layer of variability or uncertainty to our code. If it doesn't work as expected, there could be a mistake in our code, or there could be something wrong with the external resource. To eliminate this layer, we are going to use a special application that will help us to test the external service. One of the applications that serves this purpose is called Postman. So let's set it up. Go to the getpostman.com website and download the app. Choose Postman for Mac and click Download. Then move the application to your Applications folder and start it. Here's how it looks like. And now let's test iTunes API. We're going to start with lookup examples. What we need is the lookup by ID. So let's keep in mind this link and go to Postman. Right here at the top is where we post our URL. We're going to start by using method get, and as we type URL into the field, we can also enable get parameters, and you can see that it's automatically filled in. We have parameter ID, and we have a number assigned to it. So now we can click send and see what happens. So this application sends the request to the server that we specified and delivers us the result. In the bottom section of the screen, we can observe the response that we received from the server. It arrives in JSON format, and we can see a few parameters here. Result count is 1, and results in the form of an array. We can also observe that the status of the response is 200, which means OK. Now let's play with incorrect requests. First, let's provide an incorrect ID. And in response to this request, we are getting 0 results. Next, let's try providing incorrect type of an ID. This time, the response status is 400, bad request. Now let's try using method post instead. For this, we need to provide parameters in the body of our request. So switch to the body tab and type an ID key and the value. And we can remove it from our GET request. Click Send, and we receive the exact same result. We can see that iTunes server responds the same way to GET and POST requests. Now let's experiment with a couple more mistakes by providing a wrong endpoint. And the response status to this is 404, page not found. And the last one we are going to try is misspelling the server name. This time you could notice that it took us longer to get response because we tried to access a non-existent server. We received a response when the request simply timed out. One important thing to remember here, in iOS only HTTPS protocol is allowed. If you try to access any server using non-secure HTTP protocol, the response will always be an error. Now it's your turn. Pause this video and experiment with the Search API. Welcome back. I'm sure you had a lot of fun. We can now conclude that iTunes API works correctly. Next thing we need to do is perform what we did here in our code. For that, we're going to use a few classes available in Swift API. The first one is URL session. It is used to manage the whole networking session. Next one is URL session configuration. It provides configuration for a session. And finally, the URL session task. That class will help us perform the actual networking task. Then within this configuration, we'll have two more classes to work with: the URL request to handle the request, and the URL response to handle the response. The base task class is not used on its own. It has subclasses that are used to perform specific tasks. There are a few available to us, like data task to send and receive data, upload task and download task to perform uploading and downloading of heavy files like videos and audios. And the last one is stream task to perform streaming. These are the basics. Next, we are going to see how all this works in practice.